6th grade lesson 4.4 is using tables to compare ratios. And so these are what they mean by a table. And we're just going to be comparing ratios to one another and seeing at what point they match, sort of like when we do with common denominator fractions. It should feel similar. So first step we will take with our word problem. A paint store makes rose pink paint by mixing 3 parts red paint to 8 parts white paint. A clerk mixes 4 parts red paint to 7 parts white paint. Did the clerk mix the paint correctly to make rose pink paint? Use the table of equivalent ratios to support your answer and use a graphic organizer to help you solve the problem. So we read it. Now we're going to go ahead and underline the question. The question is, did the clerk mix the paint correctly in the ratios that he needed to have it be the right color? Circle the information we were given. The right mixture is 3 parts red to 8 parts white. And the clerk mixed it 4 parts red to 7 parts white. So we'll have to kind of take a look at that. We have a ratio of 3 red to 8 white compared to 4 red to 7 white. And the table is kind of a useful way to draw things out too. Notice they have this 3 parts red to 8 parts white for the way it's supposed to be. And then over here we have 4 parts red to 7 parts white for what the clerk paint mixture was. And let's go ahead and run through just like equivalent fractions. Remember they also talked about using that multiplication grid if you need to, the 3 row and the 8 row. So 3, 6, 9, 12, we're going to go 8, 16, 24, 32. Those would be equivalent ratios. 3 to 8 ratio is equivalent to 6 to 16 ratio, which is equivalent to a 9 to 24 ratio, which is equivalent to a 12 to 32 ratio. The way the clerk mixed it was a 4 to 7 ratio, 4 to 7. Here is 7, 14, 21, 28. Let's do the 4s, 4, 8, 12, 16. And what we want to do is find one where it matches. And here's where we have a match. We have the 12 to 32 ratio and a 12 to 21 ratio. Well, if those were equivalent, then they would be the same thing. It's 12 parts of red paint. This one's supposed to be 32 parts of white paint in that ratio, but the clerk did 12 parts of red paint to 21 parts of white paint. So that's going to be much more red than the way it's supposed to be. Fuchsia, I guess. So this lesson is just about comparing the ratios and using tables to help you. Remember in previous lesson, if the tables help, having those multiplication grids handy might be useful for you, so feel free to have those handy if that helps. Let's try another problem. In Amy's art class, the ratio of brushes to students is 6 to 4. In Tracy's art class, the ratio of brushes to students is 9 to 6. Is the ratio of brushes to students in Amy's class equivalent to the ratio of brushes to students in Tracy's class? Use tables of equivalent ratios to support your answer. So I've read the question. Now I'm going to underline the question it's asking me. It's asking me, is the ratio of brushes to students in Amy's class equivalent to the ratios of brushes to students in Tracy's class? And it says to use tables to support our answer. So we'll draw those tables. Step 3, when we are doing word problems. So step 1 is read it. Step 2 is underline the question. Step 3, circle the information they gave us. Amy's art class has brushes to students of 6 to 4. And in Tracy's art class, brushes to students is 9 to 6. Step 4 is to draw it. So we have Amy, and they have brushes to students. Actually, I'm going to write it as a up and down ratio. Brushes to student is 6 to 4. And in Tracy's class, brushes to student is 9 to 6. And they want to know if those are equivalent ratios, and they want us to use a table. So we'll draw two separate tables. Okay, so I've done the tables, brushes to students. So I'm going to go ahead and put this ratio 6:4 in our brushes to students. And if I wanted to have that multiplication table out, I could go ahead and count by 6s along this row and count by 4s along this row for equivalent ratios. There's 12, 18, and here I would have 4, 8, 16. Maybe that's enough. We'll compare it over here. Now I'm going to use Tracy's class. They have 9 brushes for every 6 students, so I'll put that here. I'll count by 9s here. 9, 18, 27. And I'll count by 6s here. 6, 12, 18. And I'm looking for a common location, like for example, here I have 18 and 18. And if they're equivalent, then whatever this is, it will be the same down here. And oh no, it's not. So an 18 to 16 ratio, which is equivalent for a 6:4 ratio, is not equivalent to an 18 to 12 ratio, which is equivalent to a 9:6 ratio. So if these don't end up being equivalent, then these are not equivalent. So we could just use those patterns to help us find a common point where we can compare their equivalency. If they had been equivalent when these both reached 18, you'd have the same number here as well, and we didn't. So that's all. That's how you do that. If you have any questions, let me know.